Friends, in this lecture, we will see what is cloud computing architecture. The cloud computing architecture comprises of many cloud components. Each of them are loosely coupled. We can broadly divide the cloud architecture into two parts. First one is the front end and second one is the back end. So each of the ends are connected through a network, usually via the internet. The following diagram shows the graphical view of cloud computing architecture. So this is the diagram which will show us how actually cloud computing architecture is. So basically two parts are there, front end and back end. Front end contains client infrastructure and back end contains various parts like management, application, service, cloud runtime, storage, infrastructure, security, all these things. All these things are comes under in backend, and front end and back end are connected with one another by using the internet. So in backend, basically there is a storage like in any database system for any application. We have some databases, and we can say that the database will work as a backend. So with respect to storage, there will be infrastructure. There will be some storage like service. Um, how the data is going to store on any cloud, and how the data is accessible to anyone, and how the backend is providing service to the users. So depending on that, all the management and security systems are concerned. So backend consists of large amount of data, so security is more important in the backend. And to communicate with the front end, application is used. For backend, there is also one application, and that application will be used for the purpose of communication with the internet. And internet will get communicate with client infrastructure. So this is the communication between front end and backend. So these are the backbones of any cloud computing architecture. Now front end refers to client part of cloud computing system. It consists of interfaces and applications that are required to access the cloud computing platform. For example, web browser. So here the idea will get clear, like how what is meant by front end. That front end refers to client part of the cloud computing. It consists of interfaces and applications that are required to access the cloud computing platform, like a web browser. And backend refers to cloud itself. So it consists of the resources required to provide cloud computing services. It comprises of huge data storage, virtual machines, security mechanisms, services, deployment models, and servers, etc. So all these are important points. Like you can say what is data storage is the simple thing. So various ways are used to store the data. Virtual machines we have seen before this lecture how virtual machine exactly works. Um, so machine will be treated as a many multiple machines, and we can use the same memory, and we can treat it as a various machines working. But it's actually a one machine. Security mechanisms are there, uh, like uh, the cloud is of various types like public cloud, private cloud, hybrid cloud, community cloud. So security is more concerned in all this, and so various type of uh, security security mechanisms one should provide while dealing with the cloud computing. Then services are there, various deployment models we have seen before this, and servers are there. So all these things are in backend only. So all these things, if working properly, then only the backend of cloud will work properly. So it is the responsibility of the backend to provide built-in security mechanism, traffic control, and protocols. So whoever is the cloud service provider, they have to take care of the things like whether the building security mechanism it is there or not. And traffic control means large amount of data is going to store daily, and number of people can use the same uh, cloud, then there should not be traffic. And there are some protocols, there are some rules which one has to follow, which user has to follow while communicating with the cloud or while uh, using the cloud. So it is the responsibility of backend. Then the server employs certain protocols known as middleware, helps the connected devices to communicate with each other. So there is one middleware kind of part in cloud which will help the devices to connect and to communicate. Like in this diagram, the internet will work as a middleware. Middleware in the sense, whatever the data or message coming from backend, internet is providing or passing that data to the front end. And whatever the message coming from front end, internet is providing that data to the back. So internet will work as a middleware in this cloud computing architecture. Next is cloud computing infrastructure. In this, so cloud infrastructure consists of servers, storage, network, management software, deployment software, and platform virtualization. So before this also we have seen all these things. Uh, Infrastructure consists of servers. Like if any cloud you are considering, then all these things comes under this. Like you should have some server, you should have some storage. So there should be network. There should be management software which will work when any deficiency or any problem comes into the cloud. Then the deployment software, how the cloud is going to deploy, various types of deployment softwares are there, and platform visualization. Hypervisor is a firmware or low-level program that acts as a virtual machine manager. It allows to share single physical instance of cloud resource between several tenants. Means whenever we are considering virtualization, so what comes under virtualization means you have to treat one machine as a many machines, and in this one hypervisor is there, and hypervisor is acting as a virtual machine manager. Means various virtual machines are running on single computer. Then right now which machine is going to use, and what work the machine is going to do. So hypervisor is going to share the single physical instance of cloud resource between several tenants. Means at a time you can use only one machine from various machines on the same machine. So management software helps to maintain and configure the infrastructure. Deployment software helps to deploy and integrate the application on the cloud. Network is the key component of cloud infrastructure. It allows to connect cloud services over the internet. It is also possible to deliver a network as utility over the internet. That is, the consumer can customize the network route and protocol. So server means server helps to compute the resource sharing and offer other services such as resource allocation and deallocation, monitoring resources and security, etc. Server play a very important role, as we all know that it is what server is exactly going to do is It is sharing the resources, various resources present with it, and only one device can access the uh, resource at a time. So server is managing all these things, resource allocation and deallocation, and monitoring the resources, providing security to the resources. So all these things are considered under server. So storage, cloud uses distributed file systems for storage purpose. If one of the storage resource fails, then it can be extracted from another one, which makes cloud computing more reliable. Then infrastructural constraint, fundamental constraint that cloud infrastructure should implement are shown in a following diagram. So here is one diagram which will show us infrastructural constraints. Constraints in the same thing, in the sense, these are some points which we have to take into consideration while deploying any cloud. So there should be transparency, there should be scalability, there should be security, there should be intelligent monitoring. So what are these points? So whenever seek first transparency. So since virtualization is the key to share resources in cloud environment, but it is not possible to satisfy the demand with single resource or server. Therefore, there must be transparency in the resource, load balancing and application so that we can scale them on demand. Like in public cloud, we have to go for on-demand services. So when we consider virtualization, uh, in this what we are doing, we are treating one machine as a mini machine. So it is also possible that uh, at the same time many machines are requesting for the same resource. So there must be transparency in resources. If one resource is utilized by uh, one one resource is utilized by uh, one machine, then it is shown to all others so that cannot go to request the same device or the same resource, so that uh, after completion of one's execution, it will be provided to another. Next is scalability. Scaling of an application delivery solution is not that easy as scaling up an application because it involves configuration overhead, and even re-architecting the network. So application delivery solution is need to be scalable, which is required the virtual infrastructure such that resources can be provisioned and deprovisioned easily. Like it should be scalable. What it means, uh, if you are considering four machines on a single machine, then also it is adjustable, and if you are considering two machines on a machine, then also it should be adjustable. So it should be scalable, like whatever resources, number of resources are getting added into it, the machine or the cloud infrastructure should be adjustable to it. Then intelligently monitoring. To achieve transparency and scalability, application solution delivery will need to be capable of intelligently monitoring all the resources are utilizing properly or not, whether if any device is requesting for any resource, then whether that device is getting that resource or not. So all these things are monitored within the cloud computing infrastructure. And finally, the security again is a major concern. Like the mega data center in the cloud should be securely architectured, and also the control node entry point in mega data center also needs to be secure. So the basic concern of any database management system is security. Likewise, in cloud computing also, for whatever type of cloud you will go, security will be key concern with it. So by using these 4 points, or by considering these 4 points, we can say that we can achieve a good infrastructure of cloud. Thank you.